600,000 tons. This is the weight of this crazy oil platform. Just for a reminder, your average truck is 2.0 tons, so you would have to multiply your truck 300,000 times. Yup, that's a lot of trucks, and this is just in terms of weight, because let's talk about the height of this giant of the oceans. This platform is so high, it's the equivalent of a 75-story building. If you prefer numbers, this platform is 224 meters high. Even massive ships look small compared to this platform. Welcome back to Factory Frontiers on YouTube. Today, we're talking about the Hibernia oil platform, a towering marvel of engineering, stands as a testament to human ingenuity in the quest for offshore oil extraction. Situated in the Atlantic Ocean, approximately 315 kilometers east-southeast of St. John's, Newfoundland and Labrador, Canada, it's anchored in the Hibernia oil field, which was discovered in 1979. The construction of this colossal structure marks a significant chapter in the history of oil exploration, signaling the move towards exploiting deep-sea petroleum resources. The development of the Hibernia platform was propelled by the challenge of extracting oil from beneath the ocean floor in waters around 80 meters deep. The platform's design and construction took into consideration the harsh environmental conditions it would face, including icebergs and severe North Atlantic storms. To withstand such formidable forces, Hibernia is built on a gravity-based structure, GBS, made of reinforced concrete designed to sit on the seabed. This base also serves as a storage cell for the oil, adding to the platform's efficiency. The gravity-based structure, or GBS for short, shows to us that the Hibernia platform is not just a marvel of engineering in terms of stability and durability. It also embodies innovative solutions for offshore oil extraction. The GBS's design incorporates a massive storage capacity, capable of holding over 1.2 million barrels of crude oil. This feature not only enhances the operational efficiency of the platform by minimizing the need for frequent oil offloading, but also significantly reduces the environmental risk associated with oil transportation in such sensitive ecosystems. Construction of the GBS involved an intricate process of pouring concrete into a gigantic mold, layer by layer, to form a solid structure that can endure the pressure and forces of the ocean. This process was carried out on land in a specially constructed dry dock, allowing for precise control over the quality and integrity of the construction. Once completed, the structure was floated to its designated location offshore, where it was carefully sunk and fixed onto the seabed. The Hibernia GBS is equipped with an advanced drilling rig that enables the drilling of wells directly through the structure, tapping into the oil reservoirs beneath the seabed. This integrated approach allows for a highly efficient drilling operation, with the GBS serving both as a platform foundation and as a conduit for extracting oil. The drilling rig mounted on the Hibernia GBS is equipped with state-of-the-art technology that enables the drilling of multiple wells directly through the structure itself. This rig is designed to handle the extreme conditions of the North Atlantic and can operate continuously, regardless of weather conditions. The capability to drill directly through the GBS is crucial because it significantly reduces the need for separate mobile drilling units and allows for a more streamlined operation. The integration of the drilling rig with the GBS is what sets the Hibernia platform apart from traditional offshore oil platforms. This setup allows the GBS not only to support the superstructure above the water, but also to act as a conduit for the oil being extracted from the wells below. By combining these functions, the Hibernia platform achieves a level of efficiency and safety that is difficult to match. Specifically, the Hibernia platform's drilling capabilities enable it to produce about 220,000 barrels of oil per day at its peak. This high level of production efficiency stems from the streamlined process of extracting, processing, and storing oil directly on the platform, reducing the time and energy needed to manage the oil. By having the drilling operations contained within the GBS, the Hibernia platform enhances its safety features. The structure's design includes multiple barriers to contain any potential leaks, significantly reducing the risk of environmental contamination. Moreover, the platform's ability to withstand icebergs and severe storms ensures that the drilling operations can continue safely, even in adverse conditions. Located off the coast of Newfoundland and Labrador, Canada, the Hibernia platform operates in one of the world's most challenging marine environments, subject to extreme weather and the presence of icebergs. The environmental regulations governing the Hibernia platform are stringent, reflecting the sensitive nature of its marine setting. These regulations are enforced by various Canadian federal and provincial agencies, including Environment and Climate Change Canada, the Canada, Newfoundland, and Labrador Offshore Petroleum Board (CNLOPB), and Fisheries and Oceans Canada. The platform's operations are subject to comprehensive environmental assessments that evaluate potential impacts on marine life, water quality, and the surrounding ecosystem. The Hibernia Management and Development Company Ltd. (HMDC), which operates the platform, is required to implement an environmental protection plan that outlines measures for pollution prevention, waste management, and emergency response. Significant investments have been made in technology and infrastructure to minimize the environmental footprint of the Hibernia operations. For instance, the platform employs cutting-edge oil-water separation technologies to treat produced water before it's discharged back into the ocean, ensuring it meets or exceeds regulatory standards for water quality. Additionally, the platform is designed to capture and reuse methane gas that would otherwise be flared, reducing greenhouse gas emissions. The Hibernia platform has also established protocols for ice management and iceberg detection, employing satellite surveillance and on-site support vessels to monitor and divert icebergs that pose a threat to the platform's safety. These measures are crucial in preventing potential collisions that could lead to oil spills. Despite these precautions, the Hibernia platform, like any large-scale offshore oil operation, faces ongoing scrutiny from environmental groups and the public. Concerns persist regarding the long-term impacts of offshore drilling on marine ecosystems, particularly in light of climate change and the global push towards renewable energy sources. The debate over offshore oil development in environmentally sensitive areas highlights the challenge of balancing energy production with environmental protection. The building of the Hibernia oil platform, beyond its gravity-based structure (GBS), presents a fascinating narrative of engineering triumphs and logistical coordination, culminating in the establishment of one of the world's largest offshore oil platforms. A comprehensive approach was adopted to address the platform's topsides, the upper decks and structures that sit atop the GBS. This phase involved the fabrication of modules or sections of the platform's topsides in various international locations. These modules were designed to support the drilling, production, and storage of oil, as well as to house the crew and all necessary equipment to ensure the platform's operational integrity. The complexity of coordinating the fabrication of these modules cannot be understated. With components being constructed in over 20 countries, each piece had to meet stringent specifications for quality, durability, and compatibility with other modules. Upon completion, these modules were transported to Bullarm, Newfoundland, Canada, which served as the central assembly site. The choice of Bullarm as the assembly site was strategic, not only for its proximity to the Hibernia field, but also for its capability to accommodate the large-scale logistical operations required for the assembly of the topsides. The assembly of the topsides at Bullarm was a monumental task, involving the integration of the prefabricated modules into a coherent, functioning platform. This phase included the installation of drilling equipment, production facilities, living quarters, and safety systems, among others. The process demanded precise engineering and careful management to ensure that all components worked together seamlessly. The successful assembly of the topsides represented a significant milestone in the project, showcasing the effectiveness of international collaboration in achieving complex engineering feats. Following the assembly, the next critical phase was the mating of the topsides with the GBS. This operation required calm weather conditions and involved floating the topsides over the GBS before lowering them into position. The precision of this operation was critical to the structural integrity and operational functionality of the platform. The completion of the Hibernia platform's construction was a testament to the ingenuity and resilience of the thousands of individuals involved, from engineers and construction workers to logistics coordinators and safety inspectors. Each contributed to overcoming the myriad challenges posed by such an ambitious project. Living and working on the Hibernia oil platform presents a unique and challenging lifestyle that intertwines the rigors of demanding work schedules with the close-knit community life inherent to such isolated environments. For those who call Hibernia their temporary home, life revolves around the ebb and flow of shifts that dictate the rhythm of their days and nights, where the demarcation between the two often blurs against the backdrop of the relentless sea. In this environment, workers find themselves immersed in a world where safety is paramount, and the awareness of the ocean's omnipresent might shapes their existence. The platform, a colossal structure designed to withstand the harshest weather conditions, becomes a self-contained city at sea. Within its confines, individuals come together, their roles intricately linked in the extraction of oil from beneath the seabed, a task that demands precision, teamwork, and an unyielding respect for the complex machinery and technologies at their disposal. Life on Hibernia is punctuated by the rigorous routines of 12-hour shifts, after which workers retreat to the modest comforts of their living quarters, spaces designed more for functionality than luxury. Despite the confines, personal touches emerge, little beacons of individuality in the uniformity of offshore life. Community spaces become the heart of social interaction, where meals are shared, stories exchanged, and bonds formed in the shared understanding of the unique challenges they face. Recreation and relaxation are carved out within the platform's limitations, where amenities such as gyms, recreation rooms, and sometimes even cinemas offer a reprieve from the relentless pace of work. Internet connections tether them to the world beyond the waves, a vital lifeline that maintains the fragile link to families, friends, and the passage of time in a world that seems removed from the rhythms of day-to-day life on shore. The stark contrast between the industrial might of the platform and the natural beauty of the surrounding ocean creates a backdrop to moments of introspection and camaraderie. Sunrises and sunsets are witnessed from vantage points high above the water, offering fleeting beauty and a reminder of the world beyond their immediate surroundings. Life on the Hibernia oil platform is a testament to human resilience and ingenuity, a balance of harnessing natural resources while contending with the formidable forces of nature. It's a life marked by the contrast of isolation and community, where every day is a reminder of the challenges faced and overcome in the pursuit of energy deep beneath the ocean's surface. Let's talk about the future of the oil field. The Hibernia oil field, first discovered in 1979, was initially expected to have a lifespan of 20 years. However, thanks to advancements in extended-reach drilling, geological and reservoir modeling technology, and regular maintenance, the projected life of the field has been extended beyond 2040. By November 2022, the Hibernia offshore production platform marked 25 years of oil production and had produced 1.2 billion barrels of oil out of the proven and probable reserves estimated at 1.812 billion barrels as of June 2022. This indicates that the Hibernia project continues to exceed initial expectations and contribute significantly to the region's economy and energy supply. If they ever need to unmount or unbuild the Hibernia oil platform, the process would involve a meticulously planned and complex series of operations. Given the platform's massive size, technological sophistication, and environmental considerations, the Hibernia platform, renowned for being the world's largest oil platform by weight, involves significant logistical, engineering, and environmental challenges in its potential decommissioning. The initial step would likely involve a comprehensive planning phase, potentially spanning several years, to ensure safety, environmental protection, and adherence to regulatory requirements. This phase would include detailed engineering studies, environmental impact assessments, and consultations with stakeholders, including government bodies, environmental organizations, and local communities. The goal would be to develop a decommissioning plan that minimizes environmental impacts and risks to personnel. Following the planning phase, the execution phase would begin with the cessation of oil production operations. This step would necessitate the safe shutdown of the platform's drilling rigs and production facilities, followed by the purging of hydrocarbons from the pipelines and processing equipment to mitigate the risks of spills or leaks. Subsequently, the dismantling of the above-water structure would commence. Given the Hibernia platform's unique gravity-based structure, the operation would require heavy-lift vessels. One might employ specialized vessels like the Thialf or the Sleipnir, two of the largest crane vessels in the world, capable of lifting thousands of tons. The topside modules, including the drilling derrick, production facilities, and living quarters, would be methodically detached and lifted onto transport barges for transport to shore. The next significant challenge would be addressing the GBS, a massive concrete structure designed to rest on the seabed. The GBS of Hibernia, filled with ballast for stability, would present a monumental task for removal. Options would include leaving the base in place if removal is deemed too risky or challenging, subject to regulatory approval and environmental assessment outcomes. If removal is required, cutting the structure into manageable pieces for removal might be considered, employing diamond wire saws or underwater explosives, with utmost care to minimize the environmental impacts. Throughout the process, environmental protection would be paramount. Measures would include monitoring for marine life, implementing spill prevention and response strategies, and ensuring the disposal or recycling of materials in an environmentally responsible manner. For example, metals from the platform structure could be recycled, while other materials might be disposed of according to environmental regulations. The timeline for such an operation would be extensive, likely spanning several years from initial planning to final removal. Costs would be significant, running into the billions of dollars, covering the logistics of heavy lifting, transportation, cutting operations, and environmental protection measures. Upon completion of the physical removal, the site would undergo environmental restoration. This step would involve seabed surveys and potentially the restoration of the marine environment to as close to its original state as possible, including the removal of any debris and the implementation of measures to encourage the return of marine life. The unmounting or unbuilding of the Hibernia oil platform would be a monumental engineering and environmental undertaking. It would require the coordination of numerous stakeholders, the application of cutting-edge technology, and a steadfast commitment to safety and environmental stewardship. Enough talk about the Hibernia platform. Let's now explore the other largest and biggest oil platforms. Let's start with the Burkett oil rig, a marvel in the engineering and petroleum extraction industries, signifying Russia's mighty leap into offshore drilling. The Burkett platform, whose name translates to Golden Eagle in Russian, stands as a testament to modern engineering and the pursuit of energy resources in extreme conditions. The journey of the Burkett oil rig began with its construction, aimed at exploiting the Sakhalin-1 oil field in the Russian Far East. This project, under the umbrella of the Sakhalin-1 consortium led by ExxonMobil, Rosneft, ONGC, Videsh, and Sodexo, marked a significant milestone in offshore drilling. The Sakhalin-1 field itself, located off the northeastern shore of Sakhalin Island in the Okhotsk Sea, was known for its challenging conditions, including icebergs, severe storms, and freezing temperatures. The construction of the Burkett platform was a colossal endeavor. It commenced around 2012, with the platform designed to withstand the harsh Arctic conditions. The rig's base was built to endure significant ice pressures, with a structure capable of supporting a topside weighing over 200,000 tons, making it one of the heaviest and most robust offshore platforms in the world. One of the most staggering aspects of the Burkett's design is its ability to resist extreme ice forces, a necessity given the icebergs and sea ice that characterize its operational environment. The platform was constructed in multiple locations worldwide, with significant parts built in South Korea and Russia, demonstrating the global collaboration inherent in such mega projects. By 2014, the Burkett rig was completed and ready to be installed at the Arkatin Dagi field, one of the 3 fields comprising the Sakhalin-1 project. Once operational, the Burkett set impressive records. With a peak production capacity, the rig was expected to produce up to 4.5 million tons of oil annually, approximately 90,000 barrels per day, highlighting its significant contribution to global energy supplies. The rig started pumping oil in early 2015, marking a new era in Russian offshore oil production. The technological advancements of the Burkett oil rig are not to be understated. It features state-of-the-art drilling and extraction technologies, allowing it to reach oil deposits located thousands of meters below the seabed, in water depths of about 35 meters. The platform's design also incorporates environmental safeguards to minimize its impact on the delicate Arctic ecosystem. With this oil rig specifically targeting the Arkatin Dagi field within the Sakhalin-1 project, the estimated operational lifespan would be closely tied to the recoverable reserves of the field and the efficiency of extraction technologies. Given that the Sakhalin-1 project itself represents one of the largest foreign direct investment projects in Russia, and considering the significant initial investment in constructing the Burkett platform, it's reasonable to infer that its operators planned for a long-term operation to maximize the return on investment. Thus, while the platform may have been initially expected to operate for several decades following its commissioning in 2015, ongoing developments, technological improvements, and economic factors could potentially extend its life further, possibly into the 2040s or beyond. On the other side, let's delve into the details of the Perdido oil rig, a marvel of modern engineering located in the Gulf of Mexico. Owned by Shell Oil Company, this deepwater spar platform is a joint venture involving Chevron and BP as well, showcasing a significant collaboration in the energy sector. The construction of the Perdido oil rig was a monumental task, completed by Technip in France and Kiewit Offshore Services in the United States, highlighting the global effort in its creation. This phase was critical in setting the stage for what would become one of the most technologically advanced offshore platforms in the world. Following the design phase, the construction began with the fabrication of the spar hull, a massive cylindrical structure designed to float vertically in the water and stabilize the platform. This task was undertaken in Pori, Finland, where the hull was constructed in sections due to its enormous size. Each section was meticulously built and then assembled to form the complete hull, which was designed to support the rig's deck and the drilling infrastructure above while anchoring it to the seabed thousands of feet below. Once the spar hull was complete, it was transported over the Atlantic to the Gulf of Mexico, a logistical operation of immense scale. This journey marked a significant milestone in the project, symbolizing the transition from construction to assembly and installation in the rig's final location. Upon arrival in the Gulf, the next phase involved attaching the mooring lines and anchors to the seabed to secure the spar hull in place. This process was critical to ensure the rig's stability and ability to withstand the dynamic ocean environment. Following this, the topside facilities, which include the drilling platform, living quarters, and other operational components, were installed. These modules were constructed off-site and brought to the rig location, where they were lifted onto the spar hull by heavy crane vessels. The final stages of construction focused on integrating the drilling and production systems, including the complex network of pipelines and technology necessary for extracting oil and gas from deep beneath the ocean floor. This integration was a highly technical process, requiring precision and expertise to ensure the rig could operate efficiently and safely. Throughout this entire process, collaboration among international teams from various countries and disciplines was essential. The construction of Perdido Oil Rig not only required advanced engineering and technological innovation, but also a coordinated effort to bring together the many components and systems that make up this offshore giant. The Perdido Oil Rig commenced operations in 2010, and with its state-of-the-art technology, it's designed to tap into the deepest waters of any offshore drilling site, reaching depths of more than 8,000 feet. This technological giant is not just an oil rig, but also a hub for collecting oil and gas from multiple fields, emphasizing its pivotal role in energy resource extraction. Projected to have a productive lifespan well into the 2050s, the Perdido Oil Rig exemplifies sustainability in the challenging environment of deepwater drilling. Oil rigs, these engineering marvels, stand as towering sentinels of human ingenuity and the relentless pursuit of energy resources. Situated in the heart of the world's vast oceans, they are not merely structures, but a testament to the brilliance and determination of those who dare to extract the very essence of the Earth's wealth from its most challenging environments. From the icy waters of the Arctic to the storm-swept expanses of the North Sea, these colossal platforms face nature's fury, yet continue to feel the world's insatiable demand for oil. As we've explored the largest and most advanced oil platforms around the globe, we've seen more than just steel and machinery. We've witnessed the spirit of innovation and the endless possibilities when human ambition meets technological prowess. These giants of the sea are not only crucial for meeting our energy needs, but also serve as a reminder of what can be achieved when we push the boundaries of engineering and technology.